We are doing the chapter 13-14 review. And so the first one we kind of went over in class. You need to know the formula for this, which is going to be 2 pi divided by b. That will be your period. Your frequency is the opposite, or the reciprocal, b divided by 2 pi. And so what I do is I take 2 pi and I divide it by 3/5. We don't like dividing by fractions, so we rewrite this as 2 pi times the reciprocal of that, which is 5/3, which turns into 10 pi divided by 3. And that would be my answer for my period. I just use this formula. And then I noticed that the frequency is just the reciprocal of that, so my period equals this. My frequency is the reciprocal, which would be 3/10 pi. And that would be the answer. Moving on to number 2. For number 2, it asked me to go ahead and locate the intersection of the terminal ray. Terminal ray just means it starts in the center. And the unit circle, and it's at 240, and it means that this is going to be one of the rays. And if I go 240, it's going to look like this. I know this is 180. If I go up another 30, that's going to be 210, plus another 30 would be 240. So this is point P. They asked me some questions after that. So I locate that on the unit circle. So you do need to know your unit circle. A, for this question. B, because if you fill out a whole unit circle on the test, you are going to get 5 points extra credit. So make sure you know the full unit circle, all the degrees, radians, and their ordered pairs. It says determine the sign. Well, I know that this ordered pair right here is more like the 60. And the 60 degree, I know, is the one. If I go here, I always start with this. Here's my 45 because they didn't put that on there. I went 1, 2, 3, 1, 2, 3, all over 2, all over 2, over 2, over 2, over 2, over 2, and that's the square root. That's the square root, and square root. And I know this one is just like this guy right here, which is the half first, and the square root of 3 over 2. Now the only difference is I know in this quadrant, what this is called quadrant 1, this is 2, this is 3, and this is 4. Oops. In the third quadrant, which is where this P is located, I know all of my X's are negative, and I know all my Y's are negative. I know everything is negative in this quadrant. So it's a -1/2 and a negative square root of 3 over 2. So if they ask me for the sign is the Y value. So I know sine of 240 is equal to negative square root of 3 over 2. And I know the cosine is the x of that coordinate. And so my answer is a -1/2. Then they asked me to write the coordinates of that. I've already written it right there. The coordinates are this right here. So that's the coordinates P. And they asked me to determine the value of tangent. To do tangent, tangent is the y value divided by the x. The y value divided by the x. So a negative square root of 3 over 2 divided by a -1/2. Well, first off, a negative and a negative are going to make a positive. We do not divide by fractions, so we take the square root of 3 divided by 2 and multiply it by the reciprocal of this, which is 2 over 1. When that happens, these 2's cancel. I end up with the square root of 3 over 1, or just the square root of 3 would be my answer for my tangent. Number 3 says, determine the period of this function. Well, it didn't show up very well on yours, but it shows up a little bit better on mine. And I'll make sure that this is a lot more clear when we get to the actual test. But if you look at this right here, if you look at here, this is 1. This is, so that's 2. This is 3. That's 4. This is 5. And if I look at this, that hits right here and that hits right here. I know these vertical lines didn't show up on your paper, so it's harder to see. But you can tell that it starts at 0 and goes to 5. Or you can use a different ordered pair if you want to. You don't have to go there. Remember, a period is when it starts to recycle. So I know here's a top, here's the top half. So those together, that's the top, and here's the bottom. I could do that, or I could go. By the way, the harder thing about this guy, it's probably easiest to use the top and the top, or a bottom and a bottom, because on here they don't give me my midline. So I'd have to find my midline in order to find the middle to where my top starts and my bottom starts over again. I hope I'm making that kind of clear. The midline is a little trickier, so actually I would use my top and my top, or even my bottom and my bottom, but the bottoms don't hit at a very nice spot. Those two tops hit at a very nice ordered pair for me to see that my x is 0, my x is 5 in this ordered pair. So 0 to 5, that means my period is 5 units long. I hope I'm explaining that fairly well. If you have questions on that one, make sure you see me. Determine the maximum and the min. The max is how high it goes, and my max is going to be a 5. Remember, that's a y value that I only care about. So my max for my y value is 5, and my min value is where's the lowest this thing goes, and the lowest it goes is -3. It says use your answer from it to determine the amplitude. To determine the amplitude, I know that I subtract these two, so I go 5 minus a -3 turns into 5 plus 3, which equals 8. Then you take that number and cut it in half, and you know your amplitude is 4, which makes that I can find my midline, and I can kind of show you what I'm talking about from before. So I know my midline is, or my amplitude is 4, so if I go up from 4 here, 1, 2, 3, 4, here is my midline. Now I can use this spot, but you see how it doesn't hit on a nice corner? That doesn't hit a nice corner. That one doesn't hit a nice corner. So it's hard to see, but I can kind of tell that if I count that out, that my period is 5. So this is my midline. It looks like it hits right here. And if I count over 1, 2, 3, 4, 5, it looks like it hits it again like I did before. But right here, I know that's a good order pair. And I know that's a good order pair. Again, remember, all this stuff is not the best line for a graph, because we can't tell if it exactly hits on that corner, because it could be 5.1 or whatever. So here we go. Use it to determine the midline. We just did that. We knew the amplitude was 4, so I go up 1, 2, 3, 4, and I know that this is a horizontal line, which is going to be a y equals. And what does y equal every time I'm on that line? 1. So that is the equation of my midline, is y equals 1. And then it says, so that's that for that question. Number 4, it asked me to determine the radian measure of angle 75. So we said you take 75 degrees. If you want to cancel out degrees, you can put degrees down on the bottom, and these degrees will cancel out, and that means pi. And then you can reduce. And when you reduce, you see that 5 goes into both of these. And when you take out 5, you get 15 here, and you get 36 here. And hopefully you recognize that that's still not simplified, because 3 goes into this one, and 3 goes into that one. 3 goes into this one, 5. 3 goes into that one, 12. And then you multiply top times top. 5 times pi is 5 pi over 12. And that would be your answer that you would leave it as. And that is in radians. I want to make sure you put radians back there. Alright. Number 5 says determine the degree measure. And they give you the radians. So we want 8 pi over 15. We're going to multiply that by 180. Over 1, or I'm sorry, over pi. And then what happens is the pi's cancel out like they're supposed to. I know that 15 and 180 have something in common. I know that 3 goes into both of them. 3 goes into this 5 times. 3 goes into this 60 times. And then 5 goes into that 1 time. 5 goes into that 12 times. And then when I multiply the 12 times 8, you get a 96, and then the pi's were gone, so degrees is the only thing left over, so it'll be 96 degrees. All Alright, it asked me to convert 3.75, and that's radians, into degrees. So I take this, and I'm going to I want to multiply by 180 degrees over pi radians, and then the radians cancel out. But the pi is still left over. Notice this didn't have a pi to cancel out. The radians cancel each other out. There's still a pi down here. And so what you're going to do, it says round your ends to the nearest hundredth. You're going to take in your calculator, you're going to multiply these two numbers. Then you're going to divide by pi. And when you do that, you should get an about 214.86 degrees. All right, last couple questions. The deer population in the country in a county forest preserve rises and falls throughout the year. The population is at approximate minimum of 216 deer in December and grows to the approximate maximum of 488 deer in June. Here's the function where x is the months and f of x is the deer population. Use the model to estimate the deer population in April. And so what I do is I say I know that December is 0 months. So if I plug this in, my x would be 0, and when I plug that in, I should get an answer of 216 deer. But they didn't ask me for December, but that's what I'm showing you. The 0 is my input for my x. Well, I'm not December, so I go January would be 1, February would be 2, March would be 3, and April would be 4. So my x would be 4 in this. So all you have to do, scroll down and give me some paper, is I need to take the f of 4, and it equals 136 sine of pi over 6 times 4 minus pi over 2 plus 352. So what I would do in my calculator is first I would take pi over 6, times it by 4. That's what I would do first. I would then subtract pi over 2. I would then make sure your calculator is in radians, and then I'm going to hit the button sign. Then I'm going to hit 100 times 136, and then I'm going to add 352, and when you do that, you should get f at 4 equals 420. If you give me a minute, I'll go ahead and show you all the stuff of how that should look. I'm actually going to try to quickly show you 2 ways to do this, one with the calculator and one actually without. This actually works out to be a nice number we could actually use our unit circle for. So here's what happens. If you do 136 sine, I'm going to try to stop writing so much. I'm going to just kind of write things or say it out loud. When you take pi and you divide it by 6, you should get an answer of 52.52359. So it should be 0.5235 minus, and then you take, and in your calculator, you don't want to clear that out. So what you want to hit is you want to hit pi button, you want to hit divide by 6, you want to then hit times by 4, and so when you do that, you should have in the calculator a 2.094. I'm just trying to write numbers as I do it, and then you're going to hit divide, or I'm sorry, subtract. So I'm going to subtract this, but I want to do this before I do the subtraction. So I hit the subtraction button in parentheses, and then I hit pi divided by 2, and I close my parentheses, and you should get a 1.5707 number. And then if you hit enter in your calculator again, you should finally get 136 sine of 5.52359. 8, and this is plus 352, and when you do that, when you make sure you're in radians, so you have to hit mode radians, you hit the sign button, you should get 0.5. So it should be 136 times 0.5 plus 352. When you times 136 by a half, you get 68. And when you add 68 to the 354, you get that 420. And I'm sorry, this should have been a 352. And that's how you get that 420. Alright, that's the calculator. Now what else you could have done is right here you can do some fraction work. I'm going to try to do it quick. What you could have done is you could have said, hey, it's 136 sine. Right here this would become 4 pi over 6 minus, I can't subtract these unless they have common denominator, so I make this a 6 by timesing by 3. So this becomes 3 pi over 6. And when I do that, and this is actually the better way to do it because I don't do any approximations, this turns into, I really want the sine of pi over 6 plus 352. And if you go to your unit circle and you look for the sine of pi over 6, that's the y value. The y value is 1/2. And that's how you get the 1/2 times this, which is 68, plus that, which is the 420. So I don't mind the proper way of doing it. This is the actual better way of doing that problem. Alright, so this is the last question we have to go over, and it's very similar to a question that we've already done. The wheel question that we did in class. Oh, I'm sorry, we have two questions. Alright, so what happens is, let's write this out. So we've got a wheel with a diameter of 24 inches, which means, so the wheel is here, all the way across is 24 inches. And it says it rotates counterclockwise on a level street at a rate of 85 inches per second. The height of P of the rim can be modeled by the sine function. So it says, okay, write the amplitude. Okay, if I remember this, this was kind of, now this one, that the circle is not below. It already tells us that it's on the level street. So right here, I know that this all the way across is 24, so that means that this is 12. And the reason that that helps me is because if I remember correctly from that problem, the amplitude would be equivalent to that radius, and so my amplitude is going to be 12. The period, think of this in real terms. The period is how long it takes for it to go around one complete time. Well, I know that this is my radius, which was 12, we talked about that, and I know to go all the way around, that would be called my circumference. And circumference from geometry is 2 pi r. Well, I just figured out that my radius is 12. 12 times 2 is 24, so my period would be 24 pi. Now here's the toughest part. To determine this question, I know so far they want me as h of x, and they just want the b. So I know h. I know h of x equals, and I know my amplitude. I know it's 12. We just found that out. Sine. Now b had something to do with my period. If you remember your period function, it was 2 pi divided by b. That equals your period. So if I look at this, I have 2 pi being divided by b is supposed to equal 24 pi. So here's what I have to do. I have to times by b, and I get 2 pi equals 24 pi times b. And then divide by 24 pi. That cancels this side. Divide by 24 pi. The pi's cancel out. This reduced to 1/12. So I know that my b is 1/12. So in here, it's going to be 1/12 x. And that's how I got my final equation for that one. Now the last thing that we need to do is this last one is a very good question. It says, determine the quadrant or quadrants in which cosine is greater than 0 and tangent is less than 0. Actually, you don't need to know too much. You just need to think about this. In order for cosine to be greater than 0, cosine is my x. I need to look in quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Where is my x going to be bigger than 0? And the answer is quadrant 1 and quadrant 4 has all my x values being positive. I don't care about my y values right now because this is cosine and cosine is just the x. Then the last one says, where is tangent of x less than 0? In order for tangent of x, tangent is y divided by x. And in order for it to be negative, that means that either y is negative or x is negative. I don't care which one, but both of them cannot be negative. And I look and I go, wait, this one right here, both my x and my y values are positive, which will not make tangent negative, so it's not this one, so that gets thrown out. In this one, I know my x is positive, but my y is negative, which would give me, check, a negative tangent, so the quadrant 4 is the only place in which this that they describe is true. All right, if you have any questions tomorrow, see me before, and then you can get those fixed, and then make sure you're ready for the test on Wednesday.